Guys, so today we're going to be talking about surface area of three-dimensional figures. So there's volume and there's surface area, which is what we kind of said would be this whole unit. Surface area talks about the outside of a three-dimensional figure. So when we talk about three-dimensional figures, we mean like prisms, pyramids, cylinders, cones, and spheres. Now, with surface area, you want to think about wrapping a present. So that's going to be like, how much wrapping paper do I need? What is the outside of the shape? Not talking about what can fill the inside. So today we're going to be focusing only on prisms, cylinders, and spheres. So we're not going to worry about cones and pyramids quite yet. That's going to be what we do next. So again, remember, surface area is the sum of the areas of all the faces. Okay, so faces meaning like of my prism, here's one face. There's lots of faces of your three-dimensional figure. So you want to think about like amount of wrapping paper needed. So what fits on the outside? Okay, so for a prism and a cylinder, they have the same formula. At least that's what it looks like. However, each is unique depending on the type of prism it is. So the formula for prisms and cylinders is 2b plus ph, where b is the area of the base, P is the perimeter of the base, and H is the height of the figure. So those are going to be really, really important concepts, which is why we learned area just the other day, because we're going to need to know basic area to get surface area. And then a sphere is a completely different formula, which is 4 pi r squared. So if you think back to the area of a circle, it's almost the same thing. You have your pi times radius squared, but you multiply by this 4. Okay, and always remember r is the radius, so that's half of your circle. Okay, so that's talking about this length right here. All right, so go ahead and flip your papers over, and we're just going to do a few examples. You guys are going to write those down, and then you will just practice with your homework assignment today. And remember, you are getting points for these notes, so make sure you're filling them out and turning them in. Front page of our notes, remember, sphere was the one that had a different formula. So 4 pi r squared. Okay, so we're going to start with this prism right here. Okay, so anytime it sort of looks like a box, you know that it's a prism. Now this one in particular is a rectangular prism, because as you can see, there are rectangles going all the way around our shape. Okay, so this can feel overwhelming because there's so many pieces to our formula. So if you remember, our surface area is 2b plus ph. Okay, that's ultimately what we're trying to find. So what I want to do is actually go through some steps. Okay, so the first step is you want to identify the shape of your base. Okay, because you could have a triangular prism, you could have a trapezoidal prism. There's lots of different types of prisms. This one deals with rectangles. So there are a couple options for your bases, and we'll talk about that. But clearly we have rectangles all the way around this shape. Okay, so what I'm going to do is just pick one of the rectangles that I can see. So I'm actually going to use a different color here. Now it's a little bit blurry, but if you look right here, this is one of the bases of my shape, right, of my 3D figure. And then if you look in the back, you can see the other side of the base. So it's sort of hard to envision without holding something. I kind of think of it as a Kleenex box. At least that's what this one looks like. So here's your bases. Okay, your base is a rectangle, right? I can know that that's a rectangular shape. So I'm going to say my base is a rectangle. Once you identify the shape of your base, what we're going to do is calculate B. Okay, remember, capital B is not just like this 12 right here, and that's what a lot of people tend to say, because that's what we're used to when we do base times height with area. Capital B is talking about the area of my base. So I actually want the area of this blue rectangle right here. Okay, so what that means is I need to be like, okay, because it's a rectangle, I know that the area of a rectangle is base times height, right? That's what we learned Monday and Tuesday of this week, or Monday and Wednesday of this week when we looked at area of different normal shapes. Okay, so I'm going to look just at my base, just at the thing I shaded in blue, and I can see that here's the base, here's the height of just that shape. So I'm going to take 12 times 5, which is 60. Okay, so my capital B is 60. The area of that base, of that blue rectangle that we shaded in, is 60. So that's capital B. The next thing we're going to do is calculate P. Okay, remember P is the perimeter of the base, not of the whole shape, not of our whole 3D figure, just of the base. So again, we're just focusing on the thing that I shaded in blue. Okay, and if you forget what that is, remember that is the perimeter of the base. Okay, so I'm just focusing on this rectangle. So if I look at it kind of in a flat sense instead of in a 3D sense, I know that this is 12 and this is 5. And because it's a rectangle, I know that the top is also 12 and the other side is also 5. So all I have to do is add up those 4 sides, right? That's what perimeter is. So that's just normal perimeter. So I'm going to say that P is 5 plus 12 plus 5 plus 12, which is going to give me 34. So now I have B, I have P. The only other thing I still need to identify is my height, and height is talking about the height of the whole prism, so of the whole 3D shape. Okay, and this is another place where people start to get a little bit confused because we want to say that the height is maybe 5, right? Because that's what this height is. But that's not the height of my prism. That's just the height of my base. So when we identify our height, you want to think about what is the piece that's connecting my two bases together. Okay, so again, remember you have the blue rectangle in front and you said we have that red rectangle in the back. So the piece that's joining those two together is this 8 right here. Okay, if you look, that is what's connecting those two bases. That's what we mean by height. So if I were to sit this prism on that blue rectangle side, 8 would be the height of my whole prism. Okay, so my height is 8. Now that I have all 3 pieces, my B, my P, and now my H, the last step is to plug into your formula. Okay, so my formula, again, is 2B plus PH. So at this point, all I'm doing is taking the values that I already have and I'm plugging them in. So that 2 is just part of it. My B was 60. Okay, that's what we calculated up here. My P, my perimeter, was 34. Okay, so I'm going to put that in here. And then my H was 8. So I'm going to plug that in here. Okay, and at this point, you are just putting this into the calculator. There's a couple of different ways you could do it. You could put it all in at once, just make sure you use parentheses. Or you could take it piece by piece. So the 2B, 2 times 60 is going to give me 120. PH, 34 times 8 is going to give me 272. Go ahead and add those two, and I get 392. And for surface area, just like normal area, your units are going to be whatever it is for that problem, so feet, but squared. All right, so that was a lot of information in one problem. So what we're going to do is look at a cylinder next. All right, and if you need to pause this video here to make sure you get all of this written down, that's totally fine. This video, I will warn you, is going to be a little bit longer just because it is one of the more involved concepts, and I want to make sure we have enough examples. So if you're at a place where you can do the examples without the video, you can feel free to stop watching, but I want to make sure that you get all of the examples that you need. So if I look at number 2, I can see that this is a cylinder, right? We know that cylinder is kind of like, think of a can of soup, okay? So step 1 We're going to use a different color because I don't feel like you can see that very well. Step 1, we know it's a cylinder, so I know that it's 2B plus pH. So I'm actually going to write that over here. Because remember, cylinders and spheres, or cylinders and prisms have the same formula. Sphere is the one that's different. So first thing, we still want to identify the shape of our base. Well, if I look at the base of, if you again think of like a can of any type, it's always a circular base. Okay, so that's pretty easy to identify. I know that my base is a circle. Anytime it's a cylinder, your base is going to be a circle. So that means when I go to calculate capital B, instead of doing base times height like I would do with a rectangle, I have to use the circle formula for area. Okay, because what I want is the area of this base, which is a circle. So to figure that out, we pretty much need to remember what is the area of a circle formula. Well, the area of a circle is always pi times your radius squared. And again, that's just something that we've learned before. So I need to make sure I have the radius. And again, you can use the pi button or you can use 3.14. Either way is okay. Now the radius of this base, it looks like they're giving me the diameter, which is the whole way across. Remember, I only want half of it. So my radius will be 4. That's what I'm going to plug in here. Okay, and we should feel pretty good about how to plug that into the calculator because that's what we worked on the week before I left, so last week. All right, when I actually multiply these, you should get 50.24 or something close to that. So that's going to be your capital B. All right, that's the area of that circular base. Step 3, I'm going to calculate P, which again is perimeter of the base. Remember, when we hear perimeter, you want to think circumference or arc length. So that's going to be that 2 times pi times radius formula. So the perimeter of a circle is always the circumference, right? So P is going to be 2 times pi times radius, which again, I'm going to use 3.14. All right, when I actually multiply those three things, I should get about 25.12. And then the last thing, what's nice about cylinders is calculating our height or identifying our height is super easy because you can tell what the height of your cylinder is. So just like with prisms, it's going to be what's connecting the two bases, but clearly the other base is up here, the other circle. So your height is just exactly what you would think. It would be 11. And now I just plug into my formula. So 2B plus pH. Okay, my base, my capital B, was 50.24. So I'm going to put that right here. My capital P, my perimeter, or my circumference, was 25.12. And my height was 11. Okay, so now all I do is plug this into the calculator. And again, you can either do it in 2 pieces or you can plug it all in at once. I normally do it in 2 pieces just to kind of break it down. But if you're comfortable using the calculator with parentheses, go for it. Just type it all in at once. So 2 times 50.24, that's going to give me 100.48. 25.12 times 11 is going to give me 276.32. When I add those together, I get 376.8, and that is in miles. But we want to square it because it is a surface area. So again, anytime you hear area, go ahead and square those units. All right, we're going to look at a sphere next, just because that is different than prisms and cylinders. So if we look back, I know it's a sphere because it's going to look like a globe, a ball, something of that sort. So we should kind of know what a sphere is. Okay, so the process for a sphere is a little bit different because you don't really have a base. It's just kind of one shape. So what I would do for spheres is first just identify what's your formula. So my surface area formula is 4 pi r squared. That is it. This is actually way easier than prisms and cylinders because there's really only one thing you need to identify, and that's your radius. Okay, because again, pi is just a number, and so is 4. So we just need to plug in our radius. So what I would say is for step 2, identify your radius, which they give to me, which is really, really nice. They could have given me the diameter, but they didn't. They gave me the radius. So my radius is 4. And then we're just going to plug things in. So 4 times pi, I'm going to put 3.14, times my radius squared, right? This is my radius. That's why I'm putting that there. When I plug that into the calculator, I should get about 200.96, and that would be inches squared. So as you can see, that problem took about a third of the time of the prisms and the cylinders. So spheres are much, much, much quicker to calculate surface area for. All right, guys, just 2 more problems. So thank you for sticking with me this long. Again, if you feel good about prisms and cylinders and spheres and you want to try to finish these notes on your own, go for it. Otherwise, stick along with me for 2 more problems. So these last 2 are both prisms, but the reason I want to show you some examples with them is because they're obviously not rectangular prisms. We have some different shapes going on. So if I look here, again, it's very hard to visualize without like having a physical shape in front of you, but I can tell that my base, so the shape that looks different from everything else, is this trapezoid right here. So this is what you call a trapezoidal prism. Okay, so I'm going to kind of outline this base to sort of make it easier on us. Okay, this is what I'm working with, is this base right here. So the steps are the exact same as what we did on number 1. We want to first identify our base. So I'm going to say my base is a trapezoid. Okay, once I identify that, it makes things easier. Afterwards, we want to calculate capital B. Now, because this is a trapezoidal prism and my base is a trapezoid, when I calculate B, I need to use the area formula for a trapezoid, not for a rectangle. So I'm not doing base times height. I have to use the area formula for a trapezoid, which, as we talked about in your area worksheet that you did Monday and Wednesday of this week, the formula is 0.5 B1 plus B2 times your height. So that is how we're going to calculate our base, or our capital B. Okay, so I need to identify, just looking at the base, the thing that I shaded in, what are the 2 bases of that trapezoid and what is the height of that trapezoid. So if you look at this picture, this is one of your bases, so I could call that B1. This top side is your other base, which I can see is a length of 8. So that's going to be my B2. Okay, so in my formula, I'm going to plug in 3 and 8 for B1 and B2. The height of that trapezoid, which is right here, is 4.3. Okay, so what I'm plugging in is 0.5 times 3 plus 8, because those were the 2 bases. Again, it doesn't matter which is B1 and which is B2. And then times my 4.3, which is my height of that base. Okay, so a couple different ways you could do it. You could right now plug it into the calculator if you use parentheses, but you have to use parentheses. Or I could just do order of operations. I know 3 plus 8 comes first, which is 11. And I'm just going to multiply everything else. Either way, you should get the same answer, which is 23.65. Okay, so that's the longest part of that problem. Once you get capital B, it goes a lot quicker. We now need to get our P, okay, because again, my formula that I'm going with is 2B plus PH, right, because it is a prism. So to get P, that's just perimeter, which means I'm just adding up the outside edges of that trapezoid. Okay, so again, I'm going to draw it flat, just like I did the rectangle in number 1. I know that this is 3 and this is 8. And if you look at the picture, these 2 sides over here are going to be both 5, okay? Because I can see 5 right there. So I know that this is 5 and this is 5. Okay, so when I go to get my perimeter, all I'm doing is adding up those 4 sides. So you have your 8, your 5, your 3, and your other 5, which should give us 21. And then my last step is to identify my height. Okay, and the height of this, again, is not the same as the height of your actual trapezoid. It's the height of the whole prism. So I want the height or the piece that is connecting the 2 trapezoids in this prism. So if you look at the shape, here is the other side of the base. Okay, it's back here. So I want the piece that's connecting the blue trapezoid to the black trapezoid because those are the 2 bases. So I can tell that that's going to be this 4 right here, because if I were to sit this prism on a trapezoid, that 4 would be the height. And this would be much easier to explain if I could show you guys physically with a trapezoidal prism. But since I'm not there to do that, just remember it is the thing that connects the 2 bases, the front base to the back base. So my height is 4. Okay, and at this point, you are just going to go ahead and plug these things into your overall formula, which every time it's a prism is 2b plus ph. And you guys will never have to memorize that formula. Again, you just like everything else, you might accidentally memorize it, but I will always give it to you like for tests and quizzes and things like that. So I know that capital B was 23.65. So I'm going to put that here. And the 2 comes out front. I know that capital P was 21 and H was 4. So just like we did with the prisms and with the cylinders, I'm just going to plug this into the calculator. Again, you can do it in one calculation or you can do it in 2 separate calculations. So if I multiply 2 times 23.65, that's going to give me 47.3. And if I multiply 21 times 4, that's going to give me 84. When I add those, I get 131.3. My units would be meters squared. All right, guys, one more problem, and then I promise we're done. And this last one is just another prism, but it's just a triangular prism. So I want you to see, again, some variation. Okay, so I know it's a prism because clearly it's not a cylinder. It doesn't look like a soup can. And clearly it's not a sphere, right? It doesn't look like a ball. Okay, so when I look at this picture, again, identify right away. I know it's a prism. So I know my overall formula will be 2b plus ph. Okay, so the same formula we've been using. So step 1, clearly my base this time is triangular, right? If you look at this picture, I can see that I have these 2 bases that look like triangles. And this one is actually much easier to visualize because you can see clearly that the 2 bases are nice and spread out. It's not like stacked on top of each other like that trapezoid one looked. So my base is a triangle. Okay, so I'm just going to go right ahead and start calculating all of my numbers. So if I know my base is a triangle, I need to now calculate capital B, which because it's a triangle, I need to take the area of a triangle formula. So again, if you look back at your assignment you did Monday and Wednesday of this week, the area of a triangle is always half times base times height. Okay, so it's going to be different depending on what your base is. When I look at this triangle, you want to be careful because there's kind of a lot of numbers floating around. So if you look at the triangle, again, I'm going to draw it sort of right side up outside of here. I know it's a right triangle because you can see this right angle in the corner. And it looks like down here I have 3. Right here I have 4. And then the slanted side was 5. Okay, so I really don't care about the 5 when it comes to calculating the area of that base. I just want the base and the height. Okay, so the base is here, the height is here, if I'm talking about that triangle, which you can see here and here in the actual shape. So the area of that triangle is 0.5 times 3 times 4, which ends up giving me 6. Right, if I were to put that into a calculator. So there is the area of my base. now I need to get the perimeter of my base. Okay, remember perimeter when it comes to triangles or any other normal shape other than a circle, you are just adding up the sides. So if I look at the 3 sides of that triangle, I have a 3, a 4, and a 5. Okay, so I'm just going to add them up, which will, again, this time give me 12. And then last, we want to identify what is the height, meaning, again, the height of the whole prism, not of just the triangle. So I know the height of my triangle is 4, but for the height of my prism, I want that side length that's connecting the 2 bases, connecting the 2 triangles. So if I look at this picture, I can see that this segment right here is joining those 2 triangles together, which means that the height of my prism is 7. Okay, so at this point I have B, I have P, and I have H, so I am good to go as far as plugging those into the overall formula. Okay, so B was 6, P was 12, and H was 7. And now all I have to do is those couple of calculations, add them together, and you are good to go. So 2 times 6 is going to give me 12. 12 times 7 gives me 84. Add them, and you should get a total of 96. And our units were meters squared. Okay, that is it for today. Once you have all these notes written down, go ahead and turn them in to Canvas, and then you want to practice with the assignment. So Mr. Bell will give you that assignment, and it's also attached on Canvas. Remember, assignments are going to be completion, so I want you to try them. If you do have specific questions, please feel free to send me an email. As long as I have time, I will try to upload some hints for some of those assignments as well. Okay, so let me know if you guys have any questions.